Question number 1. What is the force between two small charged spheres having charges of 2 into 10 raised to minus 7 Coulomb and 3 into 10 raised to minus 7 Coulomb placed 30 centimeter apart in air? Consider two small charged spheres Q1 and Q2. They are separated by a distance r equal to 30 centimeter. Given Q1 equal to 2 into 10 raised to minus 7 Coulomb, Q2 that is 3 into 10 raised to minus 7 Coulomb, R that is 30 centimeter, this is equal to 0.3 meter. Now we have to find the force between these two small charged spheres. According to Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Now substitute the values. 1 by 4 pi epsilon 0, it's a constant, that is 9 into 10 raised to 9 into Q1, it is 2 into 10 raised to minus 7 Coulomb into Q2, it is 3 into 10 raised to minus 7 Coulomb, all divided by R square, that is 0.3 square. This is equal to 6 into 10 raised to minus 3 Newton. Therefore, the force between these two small charged spheres is 6 into 10 raised to minus 3 Newton. Since these two spheres are of same charges, both are positive charges, so the force between them will be repulsive in nature. This is repulsive force. Question number 2. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? Consider two charges Q1 and Q2, where Q1 is 0.4 microcoulomb, Q2 is minus 0.8 microcoulomb. These two charges are separated by distance r. Given the force on one sphere due to another sphere is 0.2 Newton. That is, F12 is equal to 0.2 Newton. Force on first sphere due to second sphere is equal to 0.2 Newton. Now we have to find the distance between these two small spheres. According to Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. From this, R square equal to 1 by 4 pi epsilon 0 Q1 Q2 by F. Now substitute the values. 1 by 4 pi epsilon 0, that is 9 into 10 raised to 9 into what is Q1, that is 0.4 microcoulomb, which is equal to 0.4 into 10 raised to minus 6 Coulomb into Q2, that is 0.8 into 10 raised to minus 6 Coulomb. We are only taking the magnitude of the values. So 0.8 into 10 raised to minus 6 Coulomb, all divided by force, that is 0.2 Newton. Therefore, R square equal to 0.0144. From this, R is equal to root of 0.0144. This is equal to 0.12 meter. B. What is the force on second sphere due to first? We know that Coulomb's law obeys Newton's third law. That is, whenever one body exerts a force on second, the second one exerts an equal and opposite force on first. This is Newton's third law. Therefore, force on Q1 by Q2 is equal to force on Q2 by Q1. Now, what is force on Q1 by Q2? That is F12. It is given 0.2 Newton. This is equal to force on Q2 by Q1, F21. Therefore, the force on second sphere due to the first one is equal to 0.2 Newton. Question number 3. Check that the ratio K square by G MEMP is dimensionless. Look up a table of physical constants and determine the value of this ratio. What does the ratio signify? So given ratio is K E square by G ME MP, where ME and MP are mass of electron and proton respectively. Now we know that the electric force between an electron and a proton at a distance r is given by 1 by 4 pi epsilon 0 Q1 Q2 by r square. This 1 by 4 pi epsilon 0 is a constant, that is K. Q1 and Q2, that is charge of electron and proton. Charge of electron and proton are same but opposite signs. So this is E into E, that is E square divided by R square. So F is equal to K E square by R square. This is equation number 1. From this, what is F E R square? That is K E square. Similarly, the gravitational force between an electron and a proton is given by G. Fg is equal to G Me MP by R square. This is equation number 2. From this, what is FgR square? That is G Me MP. Now given ratio is K square by G Me MP. Now substitute the values. This is equal to K square, that is Fe R square divided by G Me MP, that is Fg R square. Now what is the dimensional formula for force? It is ml t raised to minus 2 into r, that is distance. It is L square divided by Fg, it is force. So ml t raised to minus 2 into distance, that is length square, distance square, that is length square. Then this will cancel each other. This is equal to M0 L0 T0. This, the given ratio is dimensionless. Now the second question is, what does the ratio signify? From equation 1 and 2, what is Fe by Fg? That is K square by G Me MP. If the distance between electron and proton are same, this R and R can be cancelled. So Fe by Fg is equal to K square by G Me MP. This is equal to, now substitute the values. What is K? It is 9 into 10 raised to 9 into E, charge of electron or proton, that is 1.6 into 10 raised to minus 19 whole square, all divided by, what is G? That is the gravitational constant, 6.674 into 10 raised to minus 11 into mass of electron, that is 9.1 into 10 raised to minus 31 kg into mass of proton, that is 1.67 into 10 raised to minus 27 kg. This is equal to 2.271 into 10 raised to 31, or this is approximately equal to 2.3 into 10 raised to 39. So the given ratio K square by G Me MP is equal to 2.3 into 10 raised to 39. This is the ratio between electric force to the gravitational force between an electron and proton when the distance between them is same or constant. So Fe by Fg is equal to 2.3 into 10 raised to 39. From this, what is Fe? That is 2.3 into 10 raised to 39 Fg. That is, electric force between an electron and a proton is 2.3 into 10 raised to 39 times stronger than the gravitational force between them. Question number 4. Explain the meaning of the statement, electric charge of a body is quantized. Electric charge of a body is quantized means total charge of a body is always an integral multiple of basic unit of charge. That is, Q is equal to Ne. N can have values like 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Which means that a body can have charges like 0e, 1e, 2e like that, but it cannot have fractional values like half e or minus 4.8e. Charges are not transferring fractions. We cannot transfer 1 by 2 electrons or 3 by 2 electrons like that. Only integral number of electrons can be transferred from one body to another. This is quantization of electric charge. Question B. Why can one ignore quantization of electric charge when dealing with macroscopic, that is, large-scale charges? At macroscopic level, we deal with charges that are enormous compared to the magnitude of charge. Now, what is magnitude of charge? That is 1.6 into 10 raised to minus 90 Coulomb. So, when you consider 1 microcoulomb charge, it contains N equal to Q by E. This is equal to 1 into 10 raised to minus 6 Coulomb by 1.6 into 10 raised to minus 19 Coulomb. This is equal to 6.2 into 10 raised to 12 electrons. Similarly, 1 Coulomb of charge contains N equal to 1 Coulomb by 1.6 into 10 raised to minus 19 Coulomb. This is equal to 6.2 into 10 raised to 18 electrons. So, 1 microcoulomb charge contains 6.2 into 10 raised to 12 electrons. Similarly, 1 Coulomb of charge contains 6.2 into 10 raised to 18 electrons, which is an extremely large number. Thus, if electrons are added or removed from such bodies, it hardly makes any change in the charge. Therefore, quantization of charge can be ignored at macroscopic level. Quantization of charge can be ignored at macroscopic level. Question number 5. When a glass rod is rubbed with a silk cloth, charges appears on both. A similar phenomena is observed with many other pairs of bodies. Now, what is that phenomena? It is called charging by friction. When one body is rubbed with another body, they get charged. This phenomena is what we call charging by friction. Explain how this observation is consistent with law of conservation of charge. Now, what is law of conservation of charge? Law of conservation of charge states that charges can neither be created nor be destroyed, but it can be transferred from one body to another. So, when you consider a glass rod and silk cloth system, this is glass rod and this is silk. When glass rod is rubbed with silk, some of the charges from glass rod is transferred to silk, and glass rod acquires a positive charge and silk cloth acquires a negative charge. Suppose if the glass rod attains plus 10 charge and silk cloth will attain a minus 10 charges, then the total sum of these two charges is equal to plus 10 minus 10, this is equal to 0. So the total sum of charges on two bodies is 0. Initially, the system are neutral. When they rub to each other, they get charged, and the total sum of the charges of two bodies is equal to 0. So before and after rubbing, the total charge of the system are same, or it is conserved. Therefore, this is consistent with law of conservation of charge. Question number 6. 4-point charges QA equal to 2 microcoulomb, QB equal to minus 5 microcoulomb, QC equal to 2 microcoulomb, and QD equal to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 cm. What is the force on a charge of 1 microcoulomb placed at the center of the square? Consider the square ABCD with sides 10 cm. Let O be the midpoint. QA, QB, QC, QD are 4 charges placed at the corners of the square. Let a 1 microcoulomb charge is placed at the center. Let it be Q0. We have to find the force on this 1 microcoulomb charge by these 4 charges. Given QA equal to QC, both are 2 microcoulomb. Because of symmetry, the force exerted by these two charges on this 1 microcoulomb charge will be same, but will act opposite direction. Hence, they will cancel each other. Similarly, QB is equal to QD. Both are minus 5 microcoulomb. Therefore, the force exerted by these two charges on this 1 microcoulomb charge will be same, but they are acting opposite direction. Hence, they will cancel each other. Therefore, the resultant force on this 1 microcoulomb charge by other 4 charges is equal to 0. We can prove this mathematically. For a square, all the sides and all the diagonals are equal. Now, what is AC and BD? From triangle ABC, AC square is equal to AB square plus BC square. Therefore, the diagonals AC and BD are 10 root 2 cm. Now we have to find the force on 1 microcoulomb charge due to QA, QB, QC and QD. Force between QA and Q0 is FA. This is equal to 1 by 4 pi epsilon 0 QA, Q0 by distance between these two charges, that is OA square. Now what is OA? OA is half of AC. This is equal to half of 10 root 2 equal to 5 root 2. Therefore, OA is 5 root 2 centimeter. So this is equal to, substitute the values. 1 by 4 pi epsilon 0, it is 9 into 10 raised to 9 into QA, that is 2 microcoulomb. So 2 into 10 raised to minus 6 into Q0, that is 1 microcoulomb. 1 into 10 raised to minus 6 coulomb, all divided by OA, that is 5 root 2 centimeter. So 5 root 2 into 10 raised to minus 2 whole square. This is equal to 3.6 Newton. Therefore, force between QA and Q0 is 3.6 Newton. Now, what is the direction of FA? Since QA and Q0 are positive charges, therefore, the force between them is repulsive force. this will be repulsive force, and the force will act along this direction, along OC. This is Fa. So this is the force on 1 microcoulomb charge due to QA, and this is a repulsive force and it will act along this direction. Therefore, Fa is 3.6 Newton and the direction is along OC. Force between QC and QO is Fc. This is equal to 1 by 4 pi epsilon 0 QC Q0 by distance between QC and QO is OC square. So OC square. This is equal to, now substitute the values. Force between QC and Q0 is 3.6 Newton. Now what is the direction of Fc? Similar to QA, QC is also a positive charge. Therefore, the force between QC and Q0 is repulsive force and that force will act along this direction. Direction of Fc is along OA because these two are same charges. So there is a repulsive force, so that will act along this direction. Therefore, direction of Fc is along OA. Now what is the force between QB and Q0? That is Fb. This is equal to 1 by 4 pi epsilon 0 QB Q0 by OB square. This is equal to 9 into 10 raised to 9 into what is QB, that is minus 5 microcoulomb. 5 into 10 raised to minus 6. We are only taking the magnitude of the values. So 5 into 10 raised to minus 6 coulomb into Q0, that is 1 microcoulomb. So 1 into 10 raised to minus 6 all divided by distance between QO and QB is OB square, that is 5 root 2 whole square, where OB is half of PD. This is equal to 5 root 2 centimeter. So 5 root 2 into 10 raised to minus 2 whole square. This is equal to 9 Newton. Therefore, force between QB and Q0 is 9 Newton. Now, what is the direction of FB? Since QB and Q0 both are opposite charges, one is minus 5 microcoulomb, other one is plus 1 microcoulomb. Therefore, the force between these two is attractive force. There is an attractive force between these two charges, and that force will act towards this direction, that is along OB. This is FB. This is the direction of FB. This is the force on 1 microcoulomb charge due to QB, and the force is acting along OB. Force between QD and Q0 is FD. This is equal to 1 by 4 pi epsilon 0 QD QO by distance between these two charges is OD square. Therefore, force between QD and QO is 9 Newton and the force is along OD. Since these two are opposite charges, the force between these two is attraction. Because of attraction, the force is towards this direction, towards D. This is FD. So, FD is along OD. This is the force on 1 microcoulomb charge due to QD, and this force is along OD. Therefore, the net force on Q0 is the vector sum of these four forces, that is F is equal to FA plus FB plus FC plus FD. Since FA is equal to FC, both are equal in magnitude but acting opposite direction. Therefore, FA is equal to minus of FC. This negative sign indicates that FA and FC are in opposite direction. Similarly, FB and FT are equal in magnitude but acting opposite direction. So FV is equal to minus of FT. The resultant force F is equal to, what is FA? That is minus of FC. And FB, that is minus of FT. Plus FC plus FT. This is equal to 0. Therefore, the resultant force on 1 microcoulomb charge placed at the center of the square is equal to 0. Question number 7. An electrostatic field line is a continuous curve. That is, a field line cannot have sudden breaks. Why not? We know that the electric field line always starts from a positive charge and it terminates at its negative charge. So if there is no negative charge here, the field line goes up to infinity. So when you place a test charge here, it experiences a continuous force in this direction. If there is a sudden break in this electric field line, which means that there is no electric field at this region. No electric field at this broken region. So a test charge here experiences a force here, 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 but here there is no force. Now what is force? F equal to QE. Because there is no electric field here, the charge has to jump from here to here to continue its motion. But we know that a charge cannot jump from one point to another. Therefore, field lines cannot have any sudden break. It is a continuous curve. Question B. Explain why two field lines never cross each other at any point. Let E1 and E2 be two electric field lines. They intersect at B. Then a tangent drawn at this line. This shows the force experienced in this direction. Now what is force? F is equal to QE. And if you consider this line, and the force will experience in this direction. Here also F is equal to QE. Two direction of electric field at one point. So when you place a test charge here, it experiences a force in this direction. It experiences a force in this direction. Two direction of force at one point. But we know that at any point, a particle will experience a force only in one direction. Therefore, two field lines never cross each other. If they cross each other, then at the point of intersection, there should be two direction of force. Two direction of force, which is not possible. Therefore, two field lines never intersect each other. Question number 8. 2-point charges QA equal to 3 microcoulomb and QB equal to minus 3 microcoulomb are located 20 cm apart in vacuum. A. What is the electric field at the midpoint O of the line AB joining the two charges? Consider two charges QA and QB. They are separated by a distance 20 cm. Let O be the midpoint. Therefore, OA and OB are equal to 10 cm. Now we have to find the resultant electric field at O due to these two charges. Let E1 be the electric field at O due to plus 3 microcoulomb charge. Now what is E1? E1 is 1 by 4 pi epsilon 0 QA, that is charge at A, divided by OA square. This is equal to 1 by 4 pi epsilon 0, it is 9 into 10 raised to 9 into what is QA, that is 3 microcoulomb. So 3 into 10 raised to minus 6 coulomb, all divided by OA square, that is 10 into 10 raised to minus 2 whole square. This is equal to 2.7 into 10 raised to 6 Newton per Coulomb. So electric field at O due to plus 3 microcoulomb is 2.7 into 10 raised to 6 Newton per Coulomb. And this E1 will act along OB, because QA is a positive charge. For a positive charge, electric field is directed away from the charge. So this is away from the charge. So this will act along this direction, E1, along OB. Similarly, E2 be the electric field at O due to minus 3 microcoulomb charge. Now what is E2? That is 1 by 4 pi epsilon 0 QB, that is charge at B divided by OB square. Now substitute the values. 9 into 10 raised to 9 into, what is QB? That is minus 3 microcoulomb. That is 3 into 10 raised to minus 6 coulomb. We are only taking the magnitude of the value. So all divided by OB square, that is 10 into 10 raised to minus 2 whole square. This is equal to 2.7 into 10 raised to 6 Newton per Coulomb. So electric field at O due to minus 3 microcoulomb is 2.7 into 10 raised to 6 Newton per Coulomb. Since this is a negative charge, electric field are towards the charge. This is towards the charge. So direction of E2 is along OB. This is E2. Now we have to find the electric field at the midpoint. So the resultant electric field at O is equal to, since E1 and E2 are acting along same direction, so the resultant A is equal to E1 plus E2. This is equal to 2.7 into 10 raised to 6 Newton per Coulomb plus 2.7 into 10 raised to 6 Newton per Coulomb. This is equal to 5.4 into 10 raised to 6 Newton per Coulomb. Since these two electric fields are acting along OB, so the resultant will also act along OB. Therefore, resultant electric field at O is equal to 5.4 into 10 raised to 6 Newton per Coulomb, and it will act along OB. Question number B. If a negative test charge of magnitude 1.5 into 10 raised to minus 9 Coulomb is placed at this point, what is the force experienced by the test charge? Now we place a negative test charge of minus 1.5 into 10 raised to minus 9 Coulomb is placed at the midpoint. We have to find the force experienced by this test charge. That is F equal to QE. Now what is Q? It is 1.5 into 10 raised to minus 9 Coulomb into E. The resultant electric field at O is 5.4 into 10 raised to 6 Newton per Coulomb. This is equal to 8.1 into 10 raised to minus 3 Newton. Therefore, the force experienced by the test charge is 8.1 into 10 raised to minus 3 Newton. And this force will act along OA, because this is a negative test charge. This is attracted by the positive charge QA at point A, and it is repelled by this negative charge QB at point B. So this will move towards this direction. So the force experienced towards this direction. So this is F. So force experience along OA. Question number 9. A system has two charges, QA equal to 2.5 into 10 raised to minus 7 Coulomb and QB equal to minus 2.5 into 10 raised to minus 7 Coulomb, located at points A, 0, 0 minus 15 centimeter and B 0, 0 plus 15 centimeter respectively. What are the total charge and electric dipole moment of the system? Let x, y, z be the coordinate axis. Consider two charges QA and QB. QA is located at point A, that is 0, 0 minus 15 centimeter. That is, it is located at minus z axis at a distance 15 centimeter from the origin. This is origin. Similarly, QB, it is located at point B, 0, 0 plus 15 centimeter. It is located at positive z axis at a distance 15 centimeter from the origin. Therefore, these two equal and opposite charges are separated by a distance d equal to 30 centimeter. Given QA is 2.5 into 10 raised to minus 7 Coulomb, QB, that is minus 2.5 into 10 raised to minus 7 Coulomb. Now we have to find the total charge and electric dipole moment of the system. Total charge Q is equal to QA plus QB. This is equal to 2.5 into 10 raised to minus 7 plus minus 2.5 into 10 raised to minus 7 Coulomb. This is equal to 0. So the total charge of the system is equal to 0. These two are equal and opposite charges, so their sum is equal to 0. Now we have to find the electric dipole moment of the system. Electric dipole moment P is equal to charge into distance. This is equal to, what is Q? That is 2.5 into 10 raised to minus 7 Coulomb into D, that is distance between these two charges. It is 30 centimeter, therefore 0.3 meter. This is equal to 7.5 into 10 raised to minus 8 Coulomb meter. Therefore, dipole moment of the system P is equal to 7.5 into 10 raised to minus 8 Coulomb meter. And the direction of this dipole moment is along negative z axis. We know that the direction of dipole moment is always from negative charge to positive charge. So here the direction is along negative z axis. This is the direction, that is along negative z axis. Question number 10. An electric dipole with dipole moment 4 into 10 raised to minus 9 Coulomb meter is aligned at 30 degree with the direction of a uniform electric field of magnitude 5 into 10 raised to 4 Newton per Coulomb. Calculate the magnitude of the torque acting on the dipole. Consider an electric dipole aligned at an angle 30 degree with an uniform electric field E. Given electric field E is equal to 5 into 10 raised to 4 Newton per Coulomb. Dipole moment P, that is 4 into 10 raised to minus 9 Coulomb meter. The dipole is aligned at an angle theta equal to 30 degree. Now we have to find the torque acting on the dipole. Torque acting on the dipole, tau is equal to PE sin theta. This is equal to 4 into 10 raised to minus 9 into what is E? That is 5 into 10 raised to 4 Newton per Coulomb into sine 30 degree. This is equal to 20 into 10 raised to minus 5 into what is sine 30? It is half. So this is equal to 10 into 10 raised to minus 5. That is 10 raised to minus 4 Newton meter. Therefore, the torque acting on the dipole is equal to 10 raised to minus 4 Newton meter. Question number 11. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 Coulomb. A. Estimate the number of electrons transfer from which to which. When a polythene piece is rubbed with a wool and polythene occurs a negative charge, which means that some of the electrons from wool is transferred to polythene, and polythene occurs negative and wool occurs a positive charge. Now our question is to find the number of electrons transfer. Let n be the number of electrons transfer from wool to polythene. Given the amount of charge on polythene piece Q, that is 3 into 10 raised to minus 7 Coulomb. This polythene occurs in negative charge, so Q is equal to minus 3 into 10 raised to minus 7 Coulomb. We know that E is equal to 1.6 into 10 raised to minus 19 Coulomb. Charge of electron is 1.6 into 10 raised to minus 19 Coulomb. We know that charge on a body is equal to Q is equal to Ne. From this, N is equal to Q by E. Now substitute the values. What is Q? It is 3 into 10 raised to minus 7 Coulomb. We are only taking the magnitude of the values. So 3 into 10 raised to minus 7 Coulomb divided by E. It is 1.6 into 10 raised to minus 19 Coulomb. This is equal to 1.87 into 10 raised to 12. So number of electrons transfer is 1.87 into 10 raised to 12. We know that n should always be an integral value. So we can approximate this value as 2 into 10 raised to 12. So the number of electrons transfer is 2 into 10 raised to 12. Question B. Is there a transfer of mass from wool to polythene? Answer is yes. Yes. There is a transfer of mass from wool to polythene because electron has certain mass. M is equal to 9.1 into 10 raised to minus 31 kg. This is the mass of electron. So n number of electrons are transferred from wool to polythene. So mass of one electron is 9.1 into 10 raised to minus 31 kg. Now what is the mass of n number of electrons? That is M is equal to Me into N. Now substitute the values, that is 9.1 into 10 raised to minus 31 into N is 2 into 10 raised to 12. N number of electrons are transferred from wool to polythene. So this is equal to 1.8 into 10 raised to minus 18 kg. Therefore, the mass transfer from wool to polythene is 1.8 into 10 raised to minus 18 kg. This is a negligible amount of mass because a small fraction of electron is only transferred from wool to polythene. So this is a negligible amount of mass.